Welcome to Programming in Modern C++. We are in week 12, the last week, and we are going to discuss the module 60, the last module of the course. In the previous module 59, we concluded about the concurrency support. We understand different synchronization issues in multi-threaded programs through examples, and left a lot of stuff for your self-study to get a better grasp on the concurrency support in C++. In this module we conclude. So, we take a quick review of the course, try to highlight some of the key take backs and little bit of what next, what can you do next. So, this is the outline. So, first let us just talk about what we have done in the course, what we could afford to do, the course summary. We have 59 modules that we have gone through, right. So, and this is the broad classification of topics, very top level classification of topics to go through in terms of learning, first learning C++, then learning modern C++. So, as you know, the first 45 modules spanning 9 weeks was dedicated to learning C++ as C++ 98 or C++ 03, starting from the fact that programming in C++ is fun, writing equivalent C++ programs corresponding to C programs. Then we looked at the procedural extensions, C++ as a better C, spent 2 weeks on object oriented design and programming with classes in C++, which is the meat of the initial discussion, then extended for inheritance, generalization, specialization of object modeling, which leads to different kinds of polymorphism, static binding, dynamic binding, multiple inheritance and so on. Other features came in terms of cast operators to manage the data types in the proper context, and as we saw later on in modern C++, the importance of cast operators are somewhat going down because you try to manage them more automatically. Then exceptions, very important for understanding the errors and handling. We have done a comparison between C and C++ styles. Then templates, which are program generators both at a function level as well as at a class level, and key for generic programming, streams for management of IO, and STL, the generic programming library in C++, particularly C++ containers, is what we have discussed. Of course, up to this point we have focused on C++ 98, C++ 03 only. And then the remaining 15 modules or 14 modules excluding the current one, we have focused on the modern C++, which is C++ 11, 14. We have not gone in beyond that because that kind of already C++ 11 itself is too huge and is empowering enough for a programmer to learn the new things on their own. So, in terms of modern C++ 11, we have discussed variety of general features, type related features, initializers, const expression and so on, but very importantly the Rvalue semantics and the move semantics. This is one of the key idea which makes lot of other features possible without that. So, like In C++03, if you have not understood constructors, you will not be able to proceed. You have understood now. Similarly, in C++11 onwards, if you have not understood Rvalue semantics and the move semantics, you will not be able to proceed at all. It is not only about optimizing copy, but it goes into spreads its tentacles, so to say, in so many different features that it becomes very critical. Lambda functions and or that is functions without name, anonymous functions and closure objects are very handy and very useful again and has a wide use. Then we have looked at multiple of class features. Most of them are convenience features, I would say. They are not path breaking features like Rvalue semantics or closure object and things like that, but they really make your programming easier in C++11 onwards. We have looked at a large number of non-class type and template features like variadic template, template variable and so on and so forth. Very specific and utilitarian is the resource management. So, this is another area where you must focus very well. Resource management was there earlier in C++03 also. There was an auto PTR, but that had lot of problems and it was not very useful in that way. So, people used to write their own smart pointers, different companies had their own smart pointers. All these have now been standardized in terms of just 3 smart pointers: unique pointer for exclusive ownership, shared pointer for shared ownership and weak pointer to solve the circularity problem, right. So, this is something again another very important aspect that you must master. And finally, as we have just concluded on the concurrency support, which takes you to a different dimension in terms of using C++11 and onwards, right. So, most of this discussion is around C++11. We have made some references to C++14, which is a key extension, but not a very large one, and very occasionally we have made references to C++17 or C++20. We also have provided 12 tutorials on 5 broad topics, which I consider that to be a good programmer in C++, modern C++, it is just not enough to know the language or programming. You need to be a master of how to build the programs, what is the preprocessor doing, what is the build pipeline, what is the make utility, how to make libraries, static libraries, dynamic libraries and so on. So, we have discussed these in 4 tutorials. Mixing of C and C++ code is a major industry issue, right. So, we have discussed about what are the issues they are in and what are the resolutions with project example. Core of using C++ in general and C++11 onwards in particular is to be able to design user defined data types like built-in types. C++03 could do that, but C++11 makes it even more compact, even more like the built-in types and so on. So, this set of 3 tutorials focus on discussing the design of variety of UDTs like fraction UDT, int, fixed size int UDT, polynomial UDT, mixing of those and so on, which should give you a good idea. They may not be very directly utilitarian, but this will give you a very good idea about how to make types in C++ and use them effectively. Certainly, one tutorial is focused again on talking at depth about using Rvalue and move semantics, because that is, as I said, is very important. Compatibility of the 2 languages, which is an outcome of the mixing experience, you can say. Compatibility of C and C++ has lot of issues. So, those are discussed in 2 tutorials. So, these are more like engineering aspects of the language. Right. At this point, I will also note that I keep on working with the course all the time. So, even after recording, certain ideas come to my mind, or I read up something interesting example and so on. So, I even after recording I keep on putting those in the presentation slides, both in the modules as well as in the tutorial, to remind you that this is not there is no disconnect. Those slides I have marked as post recording at the top, so that you do not get confused. But I will always suggest that besides referring to the video, do refer to the presentation files alongside, because you will get in some cases you will get more clarification, more examples, maybe minor added features or use models are discussed in this way. Now, beyond the tutorial, 12 tutorials that I have already recorded, I plan to record some more. The first 2 have been requests have come from the live sessions only, embedded C++ and CMake, which I did not get time till now to record, but I will record and make them available. Then a set of tutorials on resource management, because that I think is very important, and several of the engineering issues like C++ coding style, how to write good code, and what does a coding style mean, and what kind of coding style industry typically recommends, and so on and so forth. And obviously tutorials on C++ processes and tools. So, it's just not making a program, you have to make a software. So, it's a task that goes on and on and on for days, months, involving the customer, fixing bugs, doing enhancement, redeployment, so on and so forth. So, design, development, build, debugging, test, source code and version management, bug tracking, lot of things need to be done. I mean, of course, these are not specific to C++, but you need to know what are those processes and what are the tools that are involved in terms of doing those processes. Of that, only for build we have covered in tutorial 1 to 4, the build part, but not the other tools. So, I intend to record a couple of tutorials around that, so that you can use them as you get into the practice. And on the design side, there is a concept called design patterns, and certain types of designs are repeatedly used, and so I would like to have 1 or 2 tutorials on that. And any suggestions I get further, I will certainly, it may take a little bit of time for me to record, but I will certainly record the corresponding tutorial and make available to you even beyond your course completion and examination, right. So, keep a watch. Now, that was in terms of what we have done overall. If we look into the features, and this specifically, what I am meaning by features is the modern C++, because that is the evolving part. The C++ 0398 is pretty stabilized. So, all features of that are already covered in the course, as well as available at multiple places. But what has happened beyond that, starting from C++ 11 to 20 as it goes on, particularly C++ 11 features. So, here I have given you a map of the major C++ 11 features, and where all you can expect the module where you can expect to find it, that just a cross reference kind of, so that it makes it easier for you to if you are trying to look for information, okay, where is null pointer, then you do not have to keep on searching, you can just go null pointer, okay, it is in module 48, open module 48, you will get that, open that video, you will get that. That list continues. Naturally, Rvalue reference, move semantics have multiple, lambda expressions have multiple, concurrency support has multiple modules, and then there are some more other features which I covered. So, this was in terms of the core language features. I had talked of several library headers also. If you open module 46, when we started with the modern part, you will see that we had put this list as what we intend to cover. So, of these obviously, we have not been able to cover everything, but those library components which we have covered, I have mentioned their names, module names were there. Important omissions are array, which is a fixed size array, which is a container, new container, forward list, which is another new container. These we did not get time, and this should have been, and tuple also. These three should have been covered, but I did not get time to do that. Maybe we will do a tutorial on containers particularly and also talk about them, right. So, this is about, but most of the other major these are also containers, but they are very similar to map and set that you have, the ordered map and ordered set that you have. But for the rest we have shown what are the modules where you will can find these. Looking in terms, this into a little different glasses through major library features like smart pointers, where we can find the major smart pointers, or say the initializer list, or the thread library discussion, or the std : function, or std : bind, and so on. That mappings are given here. So, that will make it easier for you to locate again. There are several new algorithms added. Some of these we have discussed, but not exhaustively, and in the algorithms part you will find that. Coming to C++ 14, there are a few major features in the language, and most of them we have covered, and most of them are not independent, like this one, this one, this one, this one, this one, this one. These are not independent features, these are improvements on C++ 11 features. Therefore, while discussing the C++ 11 feature itself, we have included the discussion of the C++ 14 feature, right. So, the corresponding modules you will find. Only there are small features like, in fact, attribute also is an extension of a C++ 11 feature. The binary literal, digit separator, very minor features, these are independent ones, but most of C++ 11 features have been given glimpsed to. In terms of the C++ 11 library features, the most important feature is certainly make unique, which is used for unique PTR, which we have covered well, and we have covered the std types. The other two have not been covered. I have not listed beyond this in terms of C++ 17 or C++ 20 features, because they would have taken a lot more time, and come on, you have to digest this itself, which is big. Now, another list which is incomplete, but I just wanted to sensitize you on, is as we are looking at additions to C++ 9803 from C++ 11 onwards, there are deprecations also. Like we used to write string as char star. In C++ 11 onwards, you are not allowed to do that. You have to either write a string literal has to be a const char star or auto. Right? You have auto PTR is deprecated, we have already told that. You have unique PTR. The increment operator for bool type is deprecated, because it has no sense, because now bool is truly a type, it is not an integer interpreted. Register keyword for storage specifier, you can use it, but it has no effect anymore. Then you have deprecation of C style cast conversion, you have deprecation of other forms of parameter binding like export and std bind and std functions to be used, and so on. So, not all of them we have explicitly discussed, those which we have, I have mentioned the modules, but it is very important to note that if you get a warning from the compiler, usually on deprecated features you will get a warning. Deprecated features does not mean that they are not usable, but it means that this feature will disappear soon from the future standards and should be avoided, right. But the deprecated feature will still be a part of the standard library for backward compatibility reasons, but it is not at all advisable to use them. So, compilers usually give errors, not errors, warnings on that. So, make sure that you check on those warnings, and if you get such, go back and check if you are using a deprecated feature, then move on, use the right feature. So, this was kind of language wise, this is what we have been able to cover. So, I talked from the perspective of the module, weekly structure, tutorials and so on, and from the language side, and what is the mapping. If I talk about key take back, obviously C++ is a multi paradigm language, is what you have lot more strongly learned. Procedural is a better C, object oriented and generic. And if you now look back, the generic part is very heavily strengthened by C++ 11, and reuse remains to be the key. So, macros also offered reuse, but kind of in today's time you will say that, well, it is very difficult to find a use case where you have to use a macro. So, you probably are not using it. Then you have library functions, function overloading, static polymorphism, dynamic polymorphism, you have templates, you have containers, algorithms. So, C++ 11 promotes safety and reuse to a great extent. If you have understood that, learned that, internalized that, then that will be the greatest learning that you have. Naturally, designing good data type, safe type is very important for C++, and while programming in C++, you must keep an eye on efficiency, because that is why the language exists, and from one version to the other, as language apparently is becoming bigger, or at least the library is becoming bigger, but the efficiency is, if not improving, at least is not degrading. That is the core focus. Safety is obviously improving. I mean, C++ 11 is lot more type safe than C++ 03 and so on and so forth. Clarity, there is a major focus on the clarity, that it should be easy to read, intuitive and easy to work with. So, the final take back is, it is an evolving language, it is a live language. So, do not think that your learning ends by doing this course, which has gone up to C++ 11 mostly, but keep learning, keep moving with the standard. C++ 03 to 11 to 14 to 17 to 20 and 23 is round the corner. It will, next year it will be there, right. So, try to always learn what is there. Over this course, in different modules, different places, I have given plethora of references, those can always be referred, but here is a one slide summary of important references. If you have to be a master of C++, C++ 11, 14 onwards, you can rely on these references, and these are typically kind of private sites which give you good idea about different features, but I would say that, like when you learn literature, you say you read the great authors, you read Shakespeare, you read Wordsworth, you read Milton and so on and so forth, or Salman Rushdie at a later point of time and so on. Similarly, here you must rely on the great authors, Scott Meyers, the creator, Stroustrup, Andrei Alexandrescu, Herb Sutter. Here I have tried to organize them according to those authors. These are, at least in my view, are the 4 great authors in the learning of C++ content from various aspects, right. So, their key works I have listed here. Then these are also very famous author, Josuttis, Van de Voorde and so on. An excellent style guide is available from Google, and in the O'Reilly there is a nice modern C++ tutorial which talks about all these 4 dialects what they have added. It is about an 80-page book, not difficult, very written in a very crisp manner, and Chankunu has been kind to put this entire book in Creative Commons license. So, in this link you do not have to buy the book, in this link you can go and download that book, right. So, these are some of the important references besides the ISO standard and so on. I did not mention the standard here because you do not really learn, you can't really learn by reading the standard, right. So, for Strauss-Troop also I have not actually mentioned the book, the Bible book, but here I am talking about practical references which a programmer, as an engineer, the developer will need to look up and quickly get clarified on different aspects of the knowledge related to the language and the programming and the usage. Regarding your examination, naturally watch the videos carefully, revise the assignments and solutions, because the final question paper is going to be exactly in the same line. Some will be recall questions from the module, some will be recall questions with little modification from the assignments, and some will be new questions. Practice lots of coding with every feature, because that is the only way you can learn. Try to design and implement complete data types. We have tutorials on that as well, and very specifically focus on resource management, lambdas, simple multi-threading and so on. These are some of the key things that you should not get challenged in the examination. Of course, given the entire course, there will not be a lot of questions on this, but there will be some key questions on these areas as well. Well, many of you ask what next, that depends on what you want to do. Obviously, learn the topics not covered. There will always be many. There are dialects which we have not covered, as I said. And as I say that breathe programming, regularly code and implement systems are the only way to keep going and keep growing. Try to read lots of programs by good coders from GitHubs and other sources. I would advise that to learn C++ better and realize, also learn Python and Java when you get time. It is not good to be a one language developer, never, right. Not in terms of your job opportunities, but in terms of your core technical skills as such. And then these are some of the future some of the subjects that are related, which you will benefit from. Of course, algorithms and data structure I have not written here because that was to be a prerequisite to doing this course, but object oriented analysis and design, NPTEL has a course on that as well. Unified modeling language, which is mostly covered in that object oriented analysis and design course. There are courses on software engineering that you must, it is always very important, because if you can just write a program, not many companies would be heavily interested in you. They will be interested, but if you know a little bit of software engineering, how processes go, how dynamics of software creation work, they will be more interested, and the more they get interested, you get a better package, right. That's the sole idea. And of course, to go forward, study the books and references that I have just mentioned in the summary. Right. So that is all that I had to share with you in this concluding remarks. So the course on modern C++ is concluded, but we will continue to create tutorials and maybe additional material for you and putting on the NPTEL site. So even in the future, you can come there and download and see those videos and make use of the, if you can make use of this knowledge and really get a good career path forward, that would be the best reward for all of us who have worked so hard on this course. All the very best. Thank you very much for being with us in this course.